we can move to another section, fundamental mathematical calculations, operations. We can introduce something like algebraic operations, logical operations, or relationship operations for the matrices. And then we will talk something about symbolic expressions, how to simplify a given symbolic result. And then they can move to something about simple number theory computations. For example, find the least greatest common divisor or something like this. So let's consider the algebraic operation of matrices. For algebraic operations, we will introduce transpose of matrices, addition, subtraction, multiplication, division. Division we have to explain it later on. We have to write division, we have to explain right division and left division. And also we can introduce powers of the matrix. Professor Chen yesterday talked you to power matrix, integer order power and also other real powers, 0.1 power, something like that. And also I will introduce dot operations of matrices. So let's see, how can we get the transpose of a matrix? In some of the mathematics books, one will denote the transpose in this way, and also some others denoted in this way. Matlab takes this kind of notation. So if you have an A matrix, if you want to get the transpose of the matrix, what you need to do simply is A prime. So you can immediately get the transpose of the matrix. The thing that this one is quite simple, but I have to say that you have to use it you have to use it in a careful way. If A is a real matrix, there is no problem. If A is a complex matrix, what you get is the conjugate of transpose the matrix. We call it the Hermitian transpose. So in that way, for complex matrices, what we get is not the real, not the direct transpose, but the transpose conjugate of the matrix. However, if you want to get a transpose of A, what you need to do is use a dot and then prime. So in this case, you can get a transpose. So for complex matrices, you have to be very careful with these two commands, the transpose, because the definition of the two are different. So these are the matrix transpose. And addition and subtraction are quite straightforward. You just use C equals to A plus B. That's enough. If they are compatible, then you can get the result. If they are not, then you can get the error warning or error message. So you can use them directly. No matter A and B are real or complex. As long as they are compatible, you can get the results. Otherwise, you will get error display. And there is a special case. If A or B is a scalar and the other one is a matrix, then you can add the scalar to all the elements in the matrix. So these two expressions are quite similar to mathematics. To the mathematical expressions, what you need to do is just use the command like this. And also for multiplication, I have given you a simple demonstrations on why if you use C programming language, you may get some errors or some bugs. But in Matlab, what you need to do is simple. A times B. If they are compatible, then you can get the right result. Otherwise, error message will be given. So if you cannot remember what about this, just ignore it. What you need to do is memorize this one. That's enough. Just learn how to avoid the pure mathematical details. What you need to do is the interface with Matlab, not the mathematical details. Matrix division. For scalar division, it is quite easy to carry out. But for matrix division, it is defined usually like left division and right division. For instance, if you have a linear equation like this, and you want to solve x for given a and b, what you need to do in Matlab is x equals a backslash b. In this case, we call it left division, which is a solution to this matrix equation. And you, in linear algebra course, you always have to assume that A is a square non-singular matrix. If it is a singular matrix, or if it is a square rectangular matrix, then you do not have any way to solve this kind of equation. However, in engineering, there are some requirements. So for this kind of linear equation, what you need to do is to take a left division of A and B, you can get the result. If A is a non-singular square matrix, then you can use the mathematical form like this. And in Matlab, what you need to do is to perform inverse to A and then multiply the result back to B. So this is the Matlab representation of this formula. Quite close.
Should that be done symbolic?
Sorry?
Should that be done in symbolic then?
Yeah. Well, if A is a non-singular square matrix, you can. If it is not, there is no solution to it, so you cannot do it. So this is the left division, and the right division is something like this. You have a linear equation which is quite different from the previous one. We have A times x. Here it is x times A. So in this case, the Matlab solution to this problem is B slash A. So you can get a solution to the equation. And if A is a singular matrix, the solution to this equation does not exist. So what we get is the square solution of it. I will explain it to you later to make the error smallest.
That's the right slash is a division.
Oh, division here. B slash A. The other one is A slash B. They are different.
And if it's not square, will work.
Sorry.
If A and B are not square, that's one.
It will work, yes. If it is not square, which sometimes means that there is no solution to this problem. At least a square solution. You can get it directly. So this is the division. And you can also get the flip so notations. I will not explain too much about this. What is the power of a matrix? When A is integer, it is easy. You can multiply several matrices together. But when A is not integer, in Matlab, we can still use the notation like this. A hash and this x could be a non-integer. So let's go back to